years after the event slipped from headline panic into that eerie quiet where humanity pretends it has moved on, a strange kind of normalcy settled over the world, a normalcy built on denial, upgraded instruments, and a fear everyone felt but no one named. And if you're hearing this now, you're hearing it from within that tension, in the space between what we say publicly and what we watch for in the dark. Because even though the sun shines and the seasons still turn, no one who lived through the first color shift of 3I-AT Ellis has ever looked at daylight the same way again. Not really. Not in the private corners of their mind, where they still ask whether light itself can remember being drained. By the time the 10th anniversary approached, the official narrative had calcified. The event was a curiosity, an anomaly of cosmic mechanics, a coincidence wrapped in misunderstood physics, and the sudden dips in solar output had been smoothed into models that made them look less like wounds and more like harmless fluctuations, easy to swallow if you were the kind of person who wanted the universe to be gentle. But deep inside the solar observatories, the ones built after the event with budgets so large they had to be classified, the people who read the raw, jittering feeds every night saw something they didn't dare tell the public. The sun's signature, its spectral heartbeat, had settled into a slightly altered rhythm, the kind of rhythm that doesn't break anything outright, but whispers that something touched it and left behind a memory. They would never say that out loud, never risk turning a quiet fear into global dread, but they watched it anyway, waited for it, because once you've seen a star dim in perfect synchrony with the color shift of an object older than your entire civilization, you don't ever really stop listening for footsteps in the dark. And then, one morning, quiet, unremarkable, the kind where the sky looks too blue to be hiding anything, the anomaly reappeared. Not a dip this time, not a feeding signature, but a pulse, a quick 3-beat oscillation so clean it cut through the noise like a knife point, and when the machines flagged it, no one moved for several seconds, as if motion might somehow make it real. Protocol said to find the failure, find the glitch, blame the detector, the software, the calibration drift, anything mundane. But when they cross-checked it across 3 stations, then 7, then 13, the pattern held. 3 pulses, evenly spaced, faint but deliberate in shape, a rhythm too precise to be random and too soft to be a threat, almost like a tap on a window. It lasted 49 seconds, just 49 seconds to undo a decade of uneasy peace. And then it vanished, leaving only a lingering rise in the solar magnetic field, the kind that suggested displacement rather than emission, like something large had brushed past the star without ever entering our detection range. They argued about it for days behind locked doors, whether it was a reply, a warning, an echo, or just another piece of cosmic static we hadn't learned to classify. And the debate tore through the scientific underground like a fault line. The skeptics called it noise, the cautious called it a signature, and the terrified called it a message. Meanwhile, the Next Time program quietly accelerated from research concept to emergency priority, because if there was even a 1% chance that the pulse meant something had heard us after the event and had chosen to acknowledge us now, then we needed to be ready. Ready not just with weapons or probes, but with something that resembled understanding. So they built the array, a lattice of microsatellites positioned in solar orbit, each with mirrors capable of modulating reflected sunlight into geometric sequences, the closest thing we could manage to a universal language written in starlight, a way to speak without assuming biology or sound or electromagnetics. They tested it in secret, directing harmless patterns into interplanetary space, knowing they might never know whether anything saw them, and yet the act of trying felt like a necessary kind of defiance. Weeks passed, then months, and the pulse did not repeat, but neither did the unease fade. It lived inside everyone who worked on the array, a low, persistent vibration of dread or hope depending on the hour. And then, in the quiet before dawn, on a day like any other, the sun flickered. Not dimmed, not drained, just flickered, like a light bulb catching a breath.
and the array's receivers caught something impossible, a distortion in spacetime just beyond Mercury's orbit, not violent like a black hole or sharp like a gravitational wave, but smooth, controlled, a ripple shaped like intention. Instruments screamed, algorithms stalled, the distortion widened, then contracted, leaving behind no object, no radiation, not even ionized dust, just a gap in data where something enormous had moved with precision beyond anything our physics could comfortably describe. And in that absence, in that quiet hole in the fabric of measurement, a single conclusion settled into the minds of everyone watching the feeds. Something had passed by us, or through us, or looked at us, something that did not behave like a comet or probe or any object we had ever catalogued. The official report called it a non-event, a censored discontinuity, a harmless phantom. But the people who saw it knew better. They saw the shape inside the numbers, the same geometry 3I AT had traced when it shifted color, the same rhythmic spacing as the pulse. And in that moment, the world entered a new phase, not panic, not war, but awareness, the sense that the silence of the universe was no longer empty but listening. Maybe we will never know what brushed past our star that day. Maybe it was only another scout, another sampler, another node in a network we are centuries too young to understand. Or maybe it was something else, something that came not to feed or measure, but to look back at the species that had thrown a weapon at its predecessor. Whatever it was, it left us with a truth we can no longer unknow. We are not just observers anymore. We are observed. And whether the next encounter brings conversation or catastrophe, we have already stepped into the story, already lit our signal in the dark, already answered a call we barely understood. There is no going back to innocence now, only forward into whatever waits beyond the next pulse.
The probe met 3I Atlas in a place human eyes will never see directly. A hard-lit corridor of space just inside Mercury's orbit, where the sun is so bright and fierce that every sensor is fighting for survival. And the object at the heart of this story is no more than a point of darkness against a field of blinding white. The first close images were almost a disappointment at a glance. Not a sleek alien machine, not a glittering lattice, just an irregular shard, a few kilometers across, pitted and scarred, wrapped in a haze of dust and gas, like any overachieving comet. But when they pushed the contrast and ran the structural filters, a different picture emerged, one that made the mission lead swear softly into his mic. The pits were arranged in patterns, not perfect grids, but quasi-regular lattices, their spacing eerily close to the wavelengths of the light band's 3I Atlas had been absorbing most strongly. Underneath the dust, radar returns hinted at layers with densities too high for simple ice and stone, stacked like nested shells. It looked less like a natural chunk of rock and more like something grown for a purpose, using whatever raw materials it had picked up on the way. As the probe coasted alongside, instruments drinking in data, the sun behind it hiccuped. The dimming came faster this time, dropping past 3% in less than 10 minutes, then 4, then 5. On Earth, skies stayed blue, but shadows deepened in a way you could feel if you were paying attention, like the air itself had thickened. Solar farms sent frantic alerts. Grid operators shuffled loads. In a few marginal ecosystems, insects delayed their evening flight by just enough seconds to confuse the bats that hunted them. Tiny shifts, almost invisible, but seeds of bigger changes if the trend continued. In the control room, all eyes went to a single screen, a live feed of solar irradiance in real time, its curve bending downward like a bow. Right next to it, the probe's telemetry, a rush of numbers describing fields, particles, spectra. 3I Atlas's color, if you can call it that, in the harsh glare near the sun, had shifted again. The white was gone, replaced by a deep, matte black that didn't just absorb light, it seemed to drink the idea of it, cutting a hole in the surrounding glare. Its emissions in high-energy bands spiked, then stabilized into a perfectly regular pulse. If earlier phases had been test patterns, this was a carrier signal, locked in. That's when the vote happened. You won't see the footage, at least not yet. You won't hear the arguments, the way someone's voice broke when they said, "If we don't act now, and the dimming keeps deepening, we might not get another chance." You won't see the mission lead staring at a photograph on his desk, a child on a beach under a bright noon sun, before nodding once, slowly. What you will feel, if you look back at the data later, is the moment when a handful of people decided to hit something that might be an artifact of a civilization older and stranger than ours, in the hope that it would bleed or break instead of adapt and retaliate. The impactors fired. On the probe's camera, they were just bright points arcing away, then streaks, then nothing. Seconds later, instruments recorded a bloom of debris around 3I Atlas, a sudden expansion of dust and fragments, spikes and particle counts. For a moment, it looked like it was working. The object's pulsed emissions stuttered, its silhouette distorted, the neat pattern of pits and shells torn and scattered. On the solar feed, the dimming curve hesitated, flattened. Somewhere on Earth, a grid operator cheered without knowing why. Then the curve did something no one had modeled. Rather than rebound immediately, the sun's output stayed low, hovering at a 5% deficit, then dipping a little more. At the same time, the dust cloud around 3I Atlas began to move against expectation. Instead of simply dispersing, it folded inward, streams of material coiling back toward a few dense knots of higher density that had survived the impact. Those knots glowed in wavelengths no one had seen from the object before, deep radio and gamma-adjacent bands, as if the thing or the process it hosted had switched to a different mode under stress, consolidating, compressing, learning. The probe died moments later, cooked by radiation and heat as its orbit carried it too close to the sun. So we don't know how that restructuring ended. All we have are the last frozen frames, fragments pulling together like iron filings in a magnetic field, the sun behind them with a halo just slightly less fierce than it had been an hour before. On Earth, the dimming lasted almost 3 hours before the sun's brightness crept back toward normal. In that time, temperatures barely budged, but markets did. So did minds. You can't tell 8 billion people that their star took a 5% hit and expect nothing to change. Governments called emergency sessions. Satellites were retasked. Religious leaders gave improvised sermons about humility. Mean culture did what it always does, turning fear into jokes and back into fear again. And under all that noise, a new, quieter understanding settled in among the people who watch the sky for a living. We had hit 3I Atlas with everything we could throw on short notice, and all we'd really learned was that breaking it didn't immediately stop the dimming. It might have even helped it reconfigure into something more efficient. Since then, there have been no more major dips, at least none above the clutter of normal solar variability. Some see that as proof that the crisis is over, that whatever 3I Atlas was doing, the impact either crippled it or scared it off. Others look at the long-term trend lines and see a faint, slow drift downward in average solar output along the exact frequencies the object once fed on, as if the scar it left on our star is still healing, or still being exploited at a gentler, more sustainable rate we can't easily detect day to day. As for 3I Atlas itself, its path took it back out of the inner solar system months ago. It's dim now, barely more than a rumor in the outermost detectors, heading towards some other patch of darkness where no one will be watching. But its legacy is still with you, right now, in the light coming through your window. Maybe it's exactly the same as it's always been. Maybe it's a fraction of a percent thinner, a little less generous. You'll never feel that difference on your skin. You will feel its weight, though, if the models are right, in crop yields years from now, in glacial melt curves that don't quite match their projections, in subtle shifts in ecosystems that no one can quite attribute to CO2 alone. That's the aftertaste of this story. Not a clean victory or a clear defeat, but a permanent uncertainty baked into every sunrise, the knowledge that our sun is not as untouchable as we once believed, and that something out there, maybe natural, maybe not, has learned how to treat it like a fuel source. The next time an all-sky survey flags a faint, fast-moving point of light on a hyperbolic path, and some junior analyst jokes about another Atlas object, someone in the room will go very quiet, remembering these graphs, these meetings, these 3 lost hours of thin daylight. And if you've made it with me all the way here, if you're listening to this with the echo of your own breathing in your ears, I'll leave you with a single thought that keeps a lot of very smart people awake at night. What if 3I Atlas wasn't an accident of nature or even a lone device, but just one node in a pattern that's been moving from star to star for longer than our species has existed? And what if, in its memory, if it has such a thing, our sun is now on a list, tagged not as visited or studied, but as edible?
Once you start asking how to stop something like 3I ATLS, you confront 2 brutal truths at the same time. First, that it's unimaginably far away compared to anything we can easily touch. And second, that whatever it's doing to the sun, it's doing it from a distance, which means you can't just shove it into the star and be done with it, because proximity clearly isn't the only factor. Still, humans are good at one thing: building things to throw at other things. Within days of the 1.4% dimming, a classified task force, with a name so bland you'd forget it if I told you, was reactivated from an old planetary defense plan. Their job had once been to figure out how to nudge asteroids. Now, it was to design a mission that could reach an interstellar object on a hyperbolic path, intercept it near perihelion, and do something. Probe it, disrupt it, blow it apart. Nobody agreed on the end game, but everybody agreed they needed more data up close. The plan that emerged was audacious even by space agency standards. Using hardware cannibalized from a canceled lunar project and propulsion systems that had been sitting in warehouses waiting for a reason to exist, they sketched out a probe that could be launched in weeks, not years, using a heavy-lift rocket already on the manifest for a deep space test. The trajectory would be brutal. A direct, high-energy burn to chase 3I ATLS down as it swept inside the orbit of Mercury, a slingshot past the sun to match its speed enough for hours, maybe a day, of close observation before the object shot back out toward the stars. Officially, the mission was sold to the public as a once-in-a-civilization opportunity to study an interstellar visitor up close, a scientific bonanza. Unofficially, in closed sessions, the engineers discussed payloads that didn't look like instruments: penetrators, kinetic impactors, shaped charges that might crack or vaporize the object at closest approach. There was a fantasy that if 3I ATLS was some kind of coherent device, breaking it would sever its connection to the sun, like smashing a straw before it finished the drink. Not everyone agreed this was wise. The theoretical crowd, the people who spent their lives thinking about energy flows and emergent systems, argued that attacking something you don't understand could be catastrophic. If 3I ATLS was storing energy, shattering it might release that energy in a less controlled way. If it was part of a larger network, if those earlier objects Arun found traces of were prototypes or scouts, then taking a swing at this one might send a signal we couldn't take back. But the timeline was unforgiving.
Extrapolations from the last few dips suggested that the next phase could push solar dimming past 3%, potentially enough to disrupt fragile ecological systems if sustained. The mission clock started. While the probe was being assembled under clean room lights, the world outside moved through its own set of emotional phases. Denial, anger, bargaining, just like the textbooks say. Some people clung to official reassurances that the effect on daily life was negligible. Others followed every leak in rumor, watching live solar data online, convincing themselves they could feel the light changing on their skin. A small but loud group insisted the whole thing was a psyop, a manufactured crisis to justify new surveillance powers and space spending. Through it all, the sun rose and set, a fraction dimmer on some days, normal on others, its variability a cruel canvas for human projection. The next dimming event, the one everyone had circled in red on their calendars, came sooner than the models predicted. 3I ATLS was still days away from the critical distance where they expected the final phase to trigger when its spectrum shifted again. This time into a stark, almost colorless white that ate chunks of the visible spectrum and spat them back out as hard UV and soft X-rays. Solar output dropped by 2.9% for nearly 2 hours. That's when ordinary people finally noticed. Streetlights came on early in cities tuned for precise twilight levels. Solar farms saw output dip below forecast enough that backup generators kicked in. In a village in northern Italy, an old farmer who had never heard the name 3I ATLS looked up from his fields and told his grandson that the daylight felt thin, like it did before a storm, but the sky was clear. The probe launched the next morning. It rose on a pillar of flame that blended easily into the news cycle. By then, rockets were nothing new. But for the people in the loop, every second of its ascent felt like a bet placed against something they barely understood. As it left Earth's shadow and deployed its panels, one of its instruments turned not toward 3I ATLS, but briefly back toward the sun, confirming what the satellite fleet already knew. The star was back to normal brightness, as if nothing had happened. Whatever 3I ATLS was doing, it wasn't permanent. Yet. The probe's cruise phase was a blur of trajectory corrections and blindfolded fear. Every new spectrum from 3I ATLS was scrutinized. Its color stayed in that harsh white mode longer than any previous phase, as if it had plateaued. Some people dared hope that this was it, that the system had maxed out and the worst was behind them. But every plateau so far had been followed by another climb. The closer the probe got, one detail stood out. 3I ATLS wasn't just reflecting and re-emitting light at random. Its emissions in high-energy bands came in pulses, regular and structured, like a heartbeat or a beacon. That pattern was what broke the last pockets of denial among the oversight committees. Natural systems can pulse, sure. Stars oscillate, geysers erupt, auroras flicker. But this was too clean, too clock-like. If you've ever listened to a recording of a pulsar, you know the feeling. The sense that something distant is speaking in a language you almost, but not quite, understand. Now imagine that sense, except the thing speaking seems to be doing it by modulating how much of your star's energy gets through to your planet. As the probe plunged inward, its thermal shields glowing, one more argument flared up on the ground. Some wanted to arm the impactors and be ready to fire as soon as instruments confirmed anything that looked like artificial structure. Others insisted they wait, gather data, and only act if the next solar dip pushed things into truly dangerous territory. The compromise they reached was uneasy and morally ugly. They'd go in with safeties off, but the final decision to strike would be made by a tiny group of people in a room in real time, based on data that would be noisy, partial, and late. If you ever doubted how much of our future can hinge on a handful of humans under bad fluorescent lighting, this is the part of the story that will cure you of that.
The turning point came on a night when nobody was supposed to be watching. By then, the teams were exhausted, cycling through shifts in windowless rooms, staring at feeds of the same two things: a point of light that kept changing color in ways no one fully understood, and a star that was starting to look a little less constant than every schoolbook had promised. Funding bodies were nervous, governments were impatient, and public communications were still painting 3I Atlas as a distant curiosity. There had been no leaks yet, at least none big enough to go viral, and that secrecy was starting to feel heavier than the data itself. On November 9th, a small archive check changed everything. A postdoc named Arun, whose job it was to cross-match 3I Atlas's behavior with historical solar anomalies, just to rule things out, requested access to an old database from a decommissioned solar mission. The recordings went back decades, through cycles of sunspots and flares, quiet years and violent ones. Buried in that noise, he found a series of faint, narrow dips that no one had ever bothered to catalog because they were irregular, rare, and didn't fit any known pattern. There were only a handful, scattered across years, unremarkable on their own. But when he plotted their timing against the reconstructed trajectories of two earlier interstellar visitors, 1I Oumuamua and 2I Borisov, and a handful of unclassified hyperbolic candidates that had never gotten official names, a thin, awful line began to draw itself across his screen. The dips clustered near the times when those objects crossed certain distances from the sun, when their paths had lined up, however briefly, with the Sun-Earth line. The signal was messy, weaker than what 3I Atlas was producing now, but it was there, like distant footsteps leading up to the bang at the door. Arun didn't sleep that night. He reran the analysis with different assumptions, different data sets, trying to make the correlation vanish. Instead, it sharpened. It was as if the solar system had been probed before, gently, almost experimentally, by smaller or less capable objects, each one testing the surface of our star, each one dimming it just a little, then vanishing back into the dark. 3I Atlas, by contrast, wasn't testing anymore. It was scaling up. When he presented his findings to the Oversight Committee the next day, the room went from chatter to silence in seconds. There's a moment in every disaster when denial stops being an option, not because the evidence is suddenly overwhelming, but because someone finally says the one sentence that locks all the scattered facts into a shape you can't unsee. For that room, the sentence was simple: this looks like a progression. The earlier objects, the old dips, the mild anomalies, those were phase 1, 2, maybe 3 of something. 3I Atlas, with its stepped color changes and increasingly deep, predictable solar dips, was phase 4 or 5. And if it was following the same underlying pattern, there was at least one more step coming, a final phase it hadn't yet reached, timed to coincide with its crossing of the critical distance where the sun would look largest from its point of view, and the Earth would sit almost perfectly behind that light. The idea landed like a physical weight. Suddenly, this wasn't just about understanding a weird rock. It was about living through the moment when a process that might have been running quietly for decades or centuries, if older records had missed earlier visitors, finally reached a strength that humans could feel in their own skin. The debate that followed was raw. Some argued that releasing the information now would cause unnecessary panic when nothing tangible had happened yet. Others insisted that hiding it would be unforgivable, especially if the next phase came with a noticeable darkening of the sky. The more cautious voices said they needed just one more cycle, one more color change and solar dip to be sure. The more frightened ones asked, what if the next step doesn't just dip? What if it drops? In the end, the decision was taken away from them. You can't put a muzzle on the entire planet. a cluster of amateur astronomers in Eastern Europe who had been independently tracking 3I Atlas's unusual colors and blogging their findings, noticed the same correlation with public solar data and posted a long, breathless thread connecting the dots. Their analysis was messy, but not wrong. Within hours, screenshots spread, then speculative videos, then headlines. Is a cosmic parasite feeding on our sun? Scientists deny vampire comet rumors. You know how the internet works. The story fractured into 1,000 memes and arguments, and the signal buried in the noise almost disappeared. Almost. That evening, as talk shows joked about interstellar vampires and markets shrugged, something quiet and irreversible shifted above us. 3I Atlas entered its next phase. This time, the color change wasn't subtle. Observers saw it even in raw, uncalibrated images. The object's core went from gold-red to a strange electric violet laced with black, like a bruise under glass. Its spectrum sprouted new lines in deep ultraviolet and soft X-ray bands, suggesting processes far more energetic than simple sunlight scattering off dust. Hours later, the sun dimmed by 1.4%. Power managers noticed it. So did airline operators who relied on precise solar models for radiation forecasts. Astrophotographers worldwide, used to the sun's stable glare, found their calibrations inexplicably off. For the first time, the dimming lasted long enough that sensitive thermometers on the ground picked up a tiny but measurable drop in surface temperature over a belt of latitudes. It wasn't much, nothing you or I would call a chill, but it was a footstep, loud and deliberate, on the bridge between the object's behavior and our everyday lives. This was the pivot your mind keeps coming back to, once you know the whole story. The moment when 3I Atlas stopped being a curiosity in space and became something reaching into the rhythms of daylight and weather. Something you could plot not just on orbital diagrams, but on energy bills and crop yields if you extrapolated far enough. From that point on, the stakes changed. The question was no longer, what is it doing, but can we stop it? And layered under that, darker and more unsettling, what if we were never meant to?
By the time anyone outside that tight inner circle heard the name 3I Atlas, the object had already gone through 2 more color phases, and the sun had dipped 2 more times, each event just a little deeper and a little longer than the last, like a heartbeat beginning to stutter. Officially, the press releases were boring. They talked about an exciting new interstellar object exhibiting unusual spectral features. They included pretty artists' impressions of a tumbling shard of rock lit by the sun. They reassured everyone that its trajectory posed no direct collision threat to Earth. But none of those carefully chosen words mentioned the graph that one ESA analyst had taped above his desk, the one where he'd drawn a red line through the sequence of solar dips and 3I Atlas color jumps and watched them line up like teeth on a gear. In principle, the sun is not fragile. It is a fusion engine 1,000,000 times more massive than the Earth, a roaring sphere of plasma that has burned for billions of years and will burn for billions more. You don't expect something the size of a city to make it flinch. That's what made the data so hard to swallow. If the dips were real, if they weren't systematics or software phantoms, then 3I Atlas had found a way to reach into that star from tens of millions of kilometers away and pull at parts of its light the way a prism pulls at colors, except this prism was selective, targeted, and getting more aggressive with each phase. The third color shift happened on a cloudless night over Hawaii. Pan-STARRS had it scheduled, Hubble had a narrow window to glance at it, and 2 new solar monitors had come online in orbit, part of a long-planned upgrade to our space weather defenses. 3I Atlas, which had been a pale, metallic gold in spectra the previous week, suddenly developed a deep, internal red component, a glow not at the surface, but seemingly from beneath it,
as if something inside the object had warmed, lit up, come online. At almost the same moment, the satellites watching the sun recorded a 0.6% dip in total irradiance, with particular suppression in specific UV bands that matched exactly the frequencies 3I Atlas had started to absorb more strongly. Correlation is not causation. That's the mantra they kept repeating in meetings, as plots layered over plots, as people who had never in their lives paid attention to the fine structure of solar output suddenly found themselves memorizing tiny fluctuations in daily curves. But there was something about the timing, about the way the dips were no longer random bumps but clean, narrow troughs, that made the hair on the back of your neck stand up even if you had never taken a physics class. Imagine sitting in a dark control room, lit only by monitors, watching a live feed of the sun's brightness as a function of time, a calm, flat line with normal 5-minute oscillations, nothing scary. Then someone says, phase change predicted in 30 seconds, and the room goes quiet. The clock ticks. And right on cue, the line on the screen bends downward, smooth and deliberate, a shallow valley that wasn't there the day before, a valley that lasts exactly as long as the new spectral lines on 3I Atlas flare brightest. That's what happened in late October. It was no longer about finding an anomaly in the noise after the fact. They had predicted, down to the minute, when the next solar dip would occur, simply by modeling when 3I Atlas would rotate and cross a certain distance threshold from the sun. And when the sun obeyed that prediction, when the brightness curve bowed like it had been pressed from far away, the room shifted from skepticism to a cold, focused fear. Outside those sealed rooms, the world went on. People commuted, scrolled, argued about politics. The slight change in daylight was buried inside normal weather. No one could feel a 0.5% loss in irradiance over an hour. But the power grid operators in Scandinavia quietly noted that their short-term solar forecasts were off in a way they hadn't been before. A team in Japan saw a tiny discrepancy in their long baseline solar constant measurements and filed it away under "to be investigated when we're less busy." The pieces of the pattern existed in dozens of different places, but 3I Atlas was the only common thread, and the only people who knew to look for it were bound by non-disclosure agreements and the heavy, unspoken knowledge that if they were wrong, they'd destroy their reputations, and if they were right, the story was too big to control. There were attempts, of course, to find safe explanations. One camp argued that what they were seeing was some new kind of solar oscillation coincidentally synchronized with the object's approach, a resonance in the turbulent plasma of the sun that just happened to wake up now. Another proposed that the satellite instruments had a shared design flaw that only manifested when the sun's spectrum was seen through the geometry of 3I Atlas's path. Conspiracy theories whispered about deliberate tampering with data streams. Each hypothesis bought them a few more days of denial, but the universe didn't care about their comfort. In early November, as 3I Atlas crossed inside the orbit of Venus, its path bent in a way that orbital dynamicists swore softly under their breath. The shift was small, technically within the error bars of early measurements, but the direction of the deviation mattered. It nudged the object closer to the line connecting the sun and Earth, as if something, whether blind physics or something more, preferred that geometry. Gravity alone could have done it, if you were generous with uncertainties. Outgassing could have added a push, but one young analyst at JPL noticed no one wanted to see. The tiny change in trajectory had occurred immediately after the latest color shift and solar dip, as if whatever process was feeding on the sun had also given 3I Atlas a little extra momentum in exactly the direction that aligned it with us. That was the night the phrase "energy harvesting" appeared in an internal memo, carefully wrapped in quotation marks, like a joke that no one was laughing at. In the weeks that followed, the mood among the people tracking the object turned from curiosity to something more like triage. They started running worst-case scenarios, not of impact, but of dimming. What happens if the dips reach 1%, 2, 5, sustained for hours instead of minutes? Crops, ecosystems, climate models, all suddenly had a new variable nobody's equations had room for. A wandering object from interstellar space that might be learning how to pull more and more energy out of our star without ever touching its surface. For now, the sun was only flinching. But if those flinches were practice, if each color phase unlocked a stronger mode of feeding, then the real question was simple and brutal. What happens when 3I Atlas reaches its final phase? The one we haven't seen yet, the phase it seems to be saving for when it's closest to the Sun-Earth line.
On a quiet Tuesday in October, the sun dimmed by 0.3%, and almost nobody on Earth noticed. But the people who did haven't really slept since. And if you stay with me to the end of this story, you'll understand why your next sunny day might not be as safe as it looks through your window. Because this isn't about climate or pollution or the usual things we blame when the world feels wrong. This is about something that came from between the stars and seems to have discovered a way to eat our sun without anyone officially admitting it out loud yet, at least not on camera, not where you or I can watch. The object has a name, a cold bureaucratic label, 3I/Atlas. The third confirmed interstellar visitor humanity has ever seen, a shard of something that does not belong to our solar system, flagged first as a faint streak in the all-sky scans of the Atlas survey, and then stitched together into a trajectory that screamed from outside, hyperbolic orbit, incoming, not bound to the sun the way our comets are. For months, it was just another curiosity for the small tribe of astronomers who still get excited about raw FITs files and faint magnitudes, a blip in data streams from Hawaii, Chile, the Canary Islands, an object with a strange but not impossible spectrum, and a path that would take it well inside Earth's orbit before slingshotting it back into the dark. But then the color started to change. At first, it was the kind of thing that only shows up when you stack images and subtract the sky. A subtle shift in the way 3I/Atlas reflected and emitted light, its spectrum bleeding from a cold metallic blue into something warmer, more complex, with unexpected emission lines that didn't fit neatly with simple ices and dust. Observers chalked it up to outgassing, to the usual story. As an object approaches the sun, its surface heats up, volatile materials vaporize, tails form, comas glow, colors drift. That's the safe explanation, the one that makes sense inside textbooks in peer-reviewed papers. And for a while, nobody had a reason to doubt it. Then came the solar dip. It showed up first in the raw feed from a small solar observatory in Spain, an automated station that measures the sun's output minute by minute for space weather forecasts and power grid models. A tiny sag in the brightness curve lasting no more than 40 minutes, shallow but sharp, like somebody pressed on the sun's dimmer switch and let go. The software flagged it as noise, a calibration error, another glitch. But 12 hours later, in a lab in Colorado, a grad student named Lena was plotting data from NASA's Source successor, a satellite that watches the sun from above Earth's atmosphere, and she saw the same dip, same time, same shape. When she overlaid the curves, ground and space, they matched almost perfectly. It was too clean to ignore. At almost exactly the same time, halfway across the world, another system was watching a different patch of the sky.
The Atlas team had scheduled a denser observing run on 3I/Atlas because someone had noticed its spectrum drifting faster than expected, its colors sliding toward a strange, layered gold like the comet K1/Atlas had shown right before it began tearing itself apart. Only this time, the hue wasn't just cosmetic, it came with narrow, bright lines in frequency bands where nothing should be glowing that strongly. When the team pulled the timestamp from the color change and compared it to the solar data, the numbers lined up within a margin that made everybody in the room go quiet. 3I/Atlas's spectrum had jumped phases within minutes of the sun's output dipping. One event could be coincidence. Two would be uncomfortable. This was three. A changing interstellar object, a global satellite, and a ground station all humming the same discordant note. The first emails went out that afternoon, careful and dry, full of error bars and caveats, sent to a handful of people who lived at the intersection of solar physics and small body dynamics. The first replies were predictable. Check your calibrations, check your pointing, check your background subtraction. The sun doesn't just blink like that, and certainly not because of something the size of a small mountain falling through space. But you could already feel it in those threads between the lines, the awareness that 3I/Atlas was not behaving like a dull rock on a simple path. In taped meetings, the language stayed calm. They called it a transient photometric anomaly, the way you call a crack on a dam an irregularity. Off-camera, on late-night calls, the phrasing was different. What if it's not just reflecting, someone asked. What if it's absorbing in a way we've never seen yet, taking an energy in a narrow band, doing something with it, and bleeding the leftovers back out as these weird emission lines? What if the sun is being shadowed from an angle we don't quite understand yet? That's where this story really begins, with a table full of exhausted scientists staring at plots and spectra and orbital diagrams, realizing that every time 3I/Atlas's color had shifted over the past month, there had been a corresponding, if tiny, anomaly in solar output in the data, a pattern so faint that no one would ever have found it if they weren't already looking right at that object. The more they aligned the timelines, the more their stomachs turned. Because 3I/Atlas wasn't just getting brighter as it neared the sun, it was changing in discrete steps, like a device flipping through modes. And each step lined up with the sun's light reaching Earth getting just a little bit weaker. Far too subtle for anyone outside that room to notice yet, but real enough that error bars alone couldn't hide it. You're going to hear a lot of reasonable explanations in this story, a lot of official statements about solar variability and benign cosmic coincidences. But as we go deeper, keep this in mind. The first people to see the pattern were trained to doubt themselves, to blame their instruments, to assume they were wrong. And yet, after weeks of trying to make the anomaly go away, they couldn't. 3I/Atlas was changing color in lockstep with small, sharp dips in the sun's brightness. And even if nobody dared to say it out loud yet, a terrifying idea was already hanging in the air, like a storm. What if this thing isn't just visiting our solar system? What if it's feeding?